All right, everybody, we have one more problem on Newton's laws explicitly, and it is going to be a box on a wedge problem. So a box lies on a 10-meter tall wedge that is inclined 30 degrees above the horizontal. If the box has a mass of 5 kilograms and the coefficient of kinetic friction between the box and the wedge is 0.15, what is the velocity of the box after it has traveled down the wedge? So first, let's start by making a free body diagram. We'll go ahead and make our wedge and a box, and then we'll put some forces on it. So I know I have a normal force and a weight that's both in the perpendicular and parallel direction. And I also have a force of friction. So how am I going to solve this problem? Well, I'm going to have to find the acceleration, and to do that, I'm going to have to look at Newton's second law. So in the perpendicular direction, I know that the normal force minus the perpendicular component of the force of gravity, which is mg cosine theta, equals 0. And that allows me to find the normal force. So I just add mg cosine theta to both sides. And I get that the normal force, in fact, equals mg cosine theta. Now I can look in the parallel direction to find the acceleration. So the sum of the forces in the parallel direction says what? The force of gravity parallel, mg sine theta, minus the force of friction, which is mu times the normal force, equals ma, or I can write it as mg sine theta minus mu mg cosine theta equals ma. And if we notice here, we have m's everywhere. So I don't even have to know the mass of this box to be able to solve it. And I can say that the acceleration experienced by this box is g sine theta minus mu g cosine theta. Now to find the velocity at the bottom, what I can say is, I can look at my kinematic equations and notice that, well, v final squared equals v initial squared plus 2a delta x. Well, delta x I know. Delta x is what? Well, it's 10 meters in the x direction. So it's going to be 10 meters divided by, or in the y direction, divided by the sine of 30 degrees. So that tells me that the final velocity squared is equal to 2a is g sine theta minus mu cosine theta times delta x, which is 10 meters, divided by the sine of theta. And that tells me that my final velocity is going to be the square root of 2 times 9.8 meters per second squared times the sine of 30 degrees minus 0.15 cosine 30 degrees times 10 meters divided by the sine of 30 degrees, which is 12.0 meters per second downhill. So that's how we can have an inclined plane problem with friction.